Problem 15. Alright, so this problem is a basic demonstration of concept 2, this one here, 2-ish, where work is, for a constant force anyway, work is the multiple of the force times the displacement times the angle between them. You get the most work when they're parallel to each other, when the force is in the same direction as the displacement, and you'll get the minimum zero work basically when they're perpendicular. So we are given the displacement, although we're given it as in component form. It's 2I minus 4J plus 3K. So what's the actual displacement? D is the square root of 2 squared plus negative 4 squared plus 3 squared, which equals, oh hey, I didn't calculate it. But it equals 5.385. Didn't do that in my head. I paused it. Anyway, so we're looking for the angle between them. If the change in kinetic energy, remember that work is the change in kinetic energy. So that's actually another concept. That's concept right here. So we're basically doing these two concepts in this problem. Work is a change in kinetic energy, and part A, the change in kinetic energy. For part A, delta KE is 30 joules. So work is 30 joules, and work equals force times displacement. I'm just going to call it delta x times cosine of the angle between them. Now, if they were parallel, then the 30 joules would have been the maximum amount of kinetic energy based on the force given, and which is 12 newtons. Force equals 12 newtons, and the displacement traveled. But as you're going to find out very quickly when we plug it into this equation, this is not the maximum amount of kinetic energy that would have been added to the system. Why do I say added? Because it's positive. That's a plus. That's messy. Plus 30 joules. Anyway, work is 30. Force is 12. Displacement is 5.3. I'm just going to do that. 85 cosine of the angle. So theta equals 62.3 degrees. Part B, it's the change in kinetic energy is negative 30, so the work is just negative 30 joules. So basically, the only thing that changes is we add a negative here, and that gives an angle of what was it? 117.7 degrees. Yeah. Which should make sense because anything like 0 to 90. So if your displacement is here, delta x, and if your force is parallel, like in the same direction, you get your maximum. But anything between 0 and 90. So if a force is like between here, it's going to be still positive work because this component of force in the direction of the displacement. So this guy right here is still in the same direction, so it's still positive work, but less and less and less until you go up that way. Then, when you're up that way, the work is 0, right? Then once you start going back greater than 90, then the component of your force, this is force, this is force, the component of your force is in the opposite direct F. F, F. The component of your force is in the opposite direction of your displacement, so that's negative work basically. So that should make sense. When the work's negative, the angle should be larger than 90. Between 90 and 180. 180 would be maximum negative work, and 90 would be 0. Alright, that's it. Bye bye.